Hello， 又见面了。如果你有关注我的频道，你就知道我会时不时的把一些我看到并认为不错的摩托车方面资讯和你分享。今天让我们一起来看看人人都很关注的摩托车扭矩和马力到底是怎么回事。
What is torque? And what is horsepower? And how is it that this 1900cc Harley makes more than twice the torque of the 636cc Kawasaki, yet the Kawasaki makes way more horsepower? I'll kick things off with some oversimplified definitions to prime your brain for understanding. Torque is strength, and horsepower is speed. With those concepts in mind, let's dive a little deeper, and I'll start with torque. Torque is a twisting motion, and you get it when force is applied at a distance from a pivot point. If you put 1 pound of force on the end of a 1-foot wrench, you've got 1 pound-foot of torque. If you apply that same 1 pound of force to the end of a 2-foot wrench, you've got 2 pound-feet of torque. More force or more distance equals more torque. Pretty straightforward, right? Well, that same force over distance scenario is what produces torque inside your engine. Combustion pressure pushes down on the piston crown, and that downward force is applied to the distance from the crank pin to the crank's axis of rotation. Every time there's a combustion stroke, the turning force produced at the crank is transferred through the transmission and final drive to your rear wheel, where it pushes you down the road. But the torque of an individual combustion stroke is brief. It's just one shove that won't get you moving very fast or take you very far. In order to cover any distance, you need that shove to happen repeatedly. And the more frequently you get that little push, the faster and farther you'll go. Well, that's what horsepower is. It's a rating of how quickly or frequently torque is applied in a given period of time. We call it horsepower because horses were the main motive force back in the 17th century when the term was coined. But the core of the word is power, and power is a measure of how quickly work gets done. In the case of a motorcycle, the work getting done is the movement of the bike down the road, with more power equaling more speed. The equation for horsepower is torque, so force times distance, multiplied by RPM, divided by a constant of 5,250. 5250 may seem random, but it's not. It's just got a bunch of math behind it that I'm not going to go into because I don't want you to click away. The point is, by introducing revolutions per minute, time becomes part of the equation. So the more torque you can stuff into the same amount of time, the more horsepower you make and the faster you go. One way to conceptualize this is to think about running. Torque is a runner's strength, say how hard you push off the ground with your stride, whereas horsepower is how quickly you're able to swing your legs to apply that strength. Some hulking linebacker may ripple the pavement with their strength, but a more lithe athlete with less muscly legs can cram more strides into less time, so they make more power. It's the same scenario with our big-inch Harley Davidson and our inline-4 sport bike. This 1900cc Street Glide makes 113 pound-feet of torque because it's got a massive engine, so lots of combustion pressure, as well as a long stroke, so a greater distance over which that combustion force is applied. Then there's our 636cc Kawasaki. It only makes 48 foot-pounds of torque because its cylinders are relatively small and it has a short crank throw. But if we look at peak horsepower figures, the roles actually reverse. The big Harley here only makes 83 horsepower, whereas the Kawasaki makes 116. What gives, right? Well, if we look at the horsepower equation, it all boils down to revs. The Harley builds revs slowly and has a low redline, only 5,500 RPM. Meanwhile, the Kawasaki zings up past 15,000 RPM. So while the Kawasaki makes a lot less torque, it's able to apply that torque almost 3 times more frequently, so its power output, and thus speed, is high. The fact is, torque and revs are at odds with each other. That's because to get torque, you typically want a longer stroke, since that corresponds to a greater distance between the crank pin and the crank center line. But a longer stroke has a faster piston speed for a given RPM, so the engine can't safely rev as high. Meanwhile, a shorter stroke engine will make less torque, but it can rev a lot higher, so it'll produce more horsepower. Vehicle weights being equal, more torque means stronger acceleration, while more horsepower means a faster top speed. Thankfully, every motorcycle comes with a way to manipulate torque in order to optimize acceleration and speed. It's called the transmission. Remember the lever length example from the beginning of this video? Well, gears are levers too, they just happen to be round. First gear is the longest lever and top gear is the shortest, with first gear providing the most acceleration and top gear offering the most speed. In summary, torque is just a twisting force. It's what turns your rear wheel and actually pushes you down the road. You can feel torque when you open the throttle. It pushes you back in the seat. Horsepower is how often that torque is applied. Horsepower is calculated from torque and is a way to measure work, with more power equaling more speed. Hopefully that clears up a bit of confusion and gives you some insight and understanding into those horsepower and torque numbers that everyone cares so much about.